So what's happening here? It's like a ladder. The side rungs of the ladder will always be intact. But the ladder can open up in the middle, as if somebody cut the steps of the ladder and pulled the two sides of the ladder apart. And that's how DNA is replicated, in the middle. So what's going to happen is a whole series of enzymes are going to go to work in the cell. For a bacterial cell, right here at the nucleoid. This is where DNA replication happens. And the cell is going to open up its DNA, copy the side strands, and close it up again. So, I'm just going to make a quick little model. Here's my DNA. And I'm going to call it SC, semi-conservative replication. I get that. My original DNA opened in the middle, and it actually opens from this end and from this end, and the two copies are made in the middle and meet in the middle. So it's going to copy from this end that way and from this end that way. Okay? You don't have to worry and get all hung up about that. You know, there's 3' and 5' ends of DNA, and there's a direction to the copying. And if you're copying in the forward direction, you're stitching forward. If you're copying the opposite direction, you have to back stitch. And when you back stitch, you make little pieces called Okazaki fragments, and then they have to be all put together properly. And then you have proofreading enzymes. And the proofreading enzymes go through and make sure everything was done correctly. And if it wasn't done correctly, you have other enzymes. We'll chop out the mistake and figure out the correct thing and put the correct thing in. So when DNA replication happens, it requires a lot of stuff. So we're going to call that our shopping list for DNA replication. It's so funny. So the last 4 years, I shouldn't tell you political stuff. And you know what? The board of directors is coming to meet in the room outside, I was just told. Anyway, my new department chair just came in and met me in the hallway. I guess this is her first day of work. So she's like starting the fall semester already. Yeah. My sentiments exactly. Very much. Anyways, so actually in Bradenton, do you know Jose Orrs, Dr. Orrs, the chem teacher? You know Jose Orrs, the chem teacher? He's the new department chair. He replaced File Sticker. But what they did this year was they decided to, instead of divide us up by department only, we're divided up by campus. So the campus department chair for Lakewood Ranch is a new lady. Her name also happens to be Jane. And so she'll be my department chair. Or at the very least, Jose will be my department chair. So anyway, so I just met her and I forgot what the whole point of that story was. But
you were going to talk politics story.
Political story.
I know, but now
Shopping list for DNA replication, then you said.
Oh yeah. So the new department chair comes, she said, well, my office will be over there, but I don't know what we're going to talk about since you're in the science department and I'm in the literature department. She goes, well, maybe we could talk about shopping. I'm like, okay, right to a good evaluation, I don't care. Alrighty. What I'm pissed about, and I've told the whole world that it's probably highly unprofessional, I apologize for it, but for 22 years I've taught at this school and always got a good evaluation. Then when, you know who, started teaching microbiology 2 years ago, she had the nerve to write me bad evaluations. The first 2 evaluations she wrote me were fine, but then when she decided to teach microbiology, all of a sudden I'm getting a bad evaluation.
Wow.
Like, really? Because I'm competition.
Because more people wanted to take your class than hers. Oh.
And it's stupid because she is a nice lady and a good teacher. Well, at least I thought so. Colton doesn't seem to agree. What?
What?
She subbed for 2 days.
Subbed for Dr. Curl?
For, who was it? She left, probably Aaron something.
Oh, Aaron Lemon, yeah.
No.
No?
This
Different
was
one?
in Byron. I don't know.
Oh, yeah, so
But
those
she
2
subbed
days
for
were
2
living
days. Her
hell.
and Bucklemeyer, and they myself.
Well, at least you didn't want to kill her.
Yeah.
That could have gotten you in trouble. It wouldn't be worth it. But thanks, I appreciate the vote of confidence.
Yeah.
So, shopping list for DNA. We'll come back to that in a second. But my point is, it's a complex of enzymes. Okay, so this is my simplified version. Now I'm going to do a slightly more complicated version. We're going to actually look at it in the loop, if I can pull it off, okay? If I can pull it off. Okay?
If you can pull it off, then how we
Yeah,
can pull it off?
we'll see. Okay, so here's my closed loop of DNA. I'm going to simplify it. This thing I call flower power. Other people call it Patrick SpongeBob strength. Okay. See, but I grew up in the 60s, so it was all about flower power. Oh, crap. Okay. Here's my nucleoid, and don't forget it's got hydrogen bonds. I just get too lazy to draw them all the time. So the loops are held together with hydrogen bonds. Blah, 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 blah. Okay. DNA replication has to be initiated. First step is initiation. There's a lot of little details we could go into that your book goes into that we really don't have time to worry about. Because as a nurse, they're going to come to you and be like, you didn't write the first step of DNA replication down on your patient's chart. And you're like, I don't remember what it is. It's initiation. Okay, so what's going to happen is this is going to replicate in 2 directions. It's going to replicate that way, and it's going to replicate that way. So in order to do that, the loop kind of has to open up. And how does the loop open up? The hydrogen bonds break. But it's temporary. They're weak attractive forces, easily formed, easily broken. So Patrick might look a little mushy for a while, if I can draw this in any meaningful way. Whatever. So the loop opens. When the loop opens, that's because the hydrogen bonds break in the middle. Right? And the new chain strand of nucleotides is going to be pieced in here, and the other chain of nucleotides is going to be pieced in here and then stitched together, ligase together. So you'll have 2 strands. So by the time you're done, you're going to end up with you got the idea. Whatever. Probably created a mutation. Good one. Okay, so the time it's done copying, right? One strand's going to be growing in one direction. That's a very messy strand, isn't it? And one's going to be growing in the other direction. And eventually, it's going to come around to the middle. When these strands are done, they start twisting up, back up again. So, we'll try to watch a little video clip, because I can't draw all that. My problem with the video clips is they're for eukaryotic DNA replication. They're not for prokaryotic DNA replication. And prokaryotic DNA replication is the same as eukaryotic DNA replication.
Right.
But eukaryotes can have multiple chromosomes. Bacteria only have one nucleoid. And it happens right at that nucleoid without a nuclear membrane, without any dancing of chromosomes or any of that stuff, so it's just a little bit different. Question?
Me?
No question? No question. Okay, so I simplified it, and then I did it slightly more challenging. All right, for DNA replication, what do you need? You need the original DNA. That's what you're going to copy. That's what you're going to copy. Second thing, you're going to need enzymes. Enzymes are going to direct every step that happens. Enzymes are going to put new nucleotides into place for the new strands. Enzymes are going to proofread. Enzymes are going to stitch together the nucleotides. And enzymes are going to stitch together the Okazaki fragments for the side that's backstitched. All that stuff. So you're going to need a complex of enzymes. We're just going to lump it all into one enzyme name, and that is DNA polymerase, which is one of the enzymes. There are many more enzymes, so we'll just put DNA polymerase and a complex of enzymes. If you're curious, go to your textbook. It lists all the different enzymes the cell could possibly have and what they're named and what their jobs are. Quite frankly, in a 6-week class, we really don't have time for that, because then I wouldn't be able to tell you cat stories. All right, so DNA polymerase enzymes. And another thing you're going to need is nucleotides, because it's a double-stranded chain of nucleotides. And if I'm going to make 2 new strands, one for each copy, right, I'm going to need more nucleotides to make the copies, right? We call those free nucleotides, which means available. If the cell is healthy,